Hi, my name is Patrick Bossman, and I'm a senior customer engineer at ScyllaDB. And today we're going to talk about how to do database migrations, some strategies, and avoiding pitfalls. So I have about 30 years of experience helping enterprise customers design and deploy solutions on databases. And so looking forward to helping some of you come to ScyllaDB. So this presentation is going to discuss some types of migrations and how to migrate from Cassandra, SQL interfaces, DynamoDB, as well as other database platforms, as well as how to tune the migrations that you would perform. So first we'll do a little migration overview. The first thing is a lot of people are scared of moving to a new database. They're afraid of migrations and what it might entail. And what I want to say to you first and foremost is we can do it. Migrations don't have to be feared. We do a lot of migrations. We perform migrations all the time, especially from SQL and DynamoDB. A lot of times there are no application changes. There's rich tooling and assistance to help you make the move. So if you take one thing away from this is that you shouldn't fear migrations. We're doing them all the time. So what are your options? Are you going to plan on doing an online migration? Do you need your application to remain up? Do you have 24/7 requirements? So that's one option that's available. Some customers do have applications that there's natural windows, and so they can do an offline migration. So we'll discuss some of the opportunities that you can do that way. And there is one particular type of migration where if you're moving from, say, one cloud to another, or if you're moving from Scylla to Scylla, across the country, regional migration, you can actually just add a data center. And so there's some really simple migrations that definitely require no application changes and are very simple to move across the country, that are very easy with a database like ScyllaDB, but might be more challenging with something like MySQL or a non-distributed database that doesn't have data center capabilities. So the first migration that I'll talk about and use an example of is migrating from Cassandra, a SQL migration, to ScyllaDB. So we'll show an example of an online migration. One of the really nice capabilities from SQL, from Cassandra migrations is that we can, and also ScyllaDB migrations, is we can preserve the write time and the TTL from the source to the target. And what this means is we can redirect new writes to the target database before we've started backfilling. And then we can backfill or forklift your data from the source to the target. And the forklifting, the older data that we're bringing into the target, does not overwrite the recently written dual writes, because it has a write timestamp that's older than the dual writes. So this makes migrating from a Cassandra style database, it makes it really easy to do that type of migration because you don't have to worry about that overwrite. And so there's a couple of tools that are available to help us do that. One of the ones that I'll talk about is ZDM proxy, zero downtime migration, and the Scylla Migrator can also help for the backfill and validation pieces. So what does a live migration look like? So you're writing to the source database. It could be Scylla, it could be Cassandra. So you're reading and writing to it, and then you create the schema in the target database. And then the next step is to enable dual writes. And so dual writes means that any insert, update, or delete that's coming into the source database is also duplexed and written to the target database. So you can either modify your application to do those dual writes directly to both databases, and a lot of customers choose to do that. The other option is using the ZDM proxy, which you would then point your application to the ZDM proxy, and it would send the writes to the original source database and the target database. So making that, it's a seamless from an application perspective, way to achieve dual writes without changing your application. But you do incur some latency overhead because you've added a hop. And how much overhead you get, it kind of depends on the proximity of the proxy to between your app and the database, right? So whatever it's adding is pretty much the latency that gets introduced there. So we're writing to both the source and the target database at this point, and then we start forklifting the data. And for that, we recommend using Scylla Migrator. If the SS tables and you have access to SS tables, you could also use that in the background and say load and stream database to Scylla from a backup. That's also viable. After the forklifting of the data is done, since we're doing dual writes, the databases are then considered in sync. And it's at this point that you can start dual reading. You can begin your validation and make sure the source and target are both, they have the same data, right? And then finally, you start writing to Scylla exclusively after you're completely comfortable with that Scylla is operating and all of the data is there and it is now the primary from a write perspective. You are writing exclusively to ScyllaDB and you fade off of your source database, which in this case is Cassandra. And so there you have it. You're done. You are migrated to ScyllaDB. And so what were the tools that we used? As I mentioned, one of them is the ZDM proxy, zero downtime migration, and that is what can abstract the dual writes so that you don't have to change your application. Alternatively, you could do dual writes in the application yourself. And the second is ScyllaDB Migrator, which is a Spark tool that is highly resistant to failures. It'll retry writes within the Spark application, and it's highly scalable. So if you have requirements on doing a fast migration, one of the wonderful things about both ScyllaDB and the ScyllaDB Migrator is they're highly scalable. And if we need to compress the migration time, then it's a matter of scaling both the database, the target database, and the Scylla Migrator to push more data faster. And then after the migration is complete, we could scale it back down and right size it to what your workload needs to actually perform. So very, very nice to have that option available to us. All right. So there are some other options that are slower, but maybe okay for smaller data sets. There's DS Bulk, which you can just basically copy data. You read from the source and pipe the output to a target. And so it's an unload-load tool. And CQLSH, which will just read from a table, write it to a CSV, and then you can load that CSV using CQLSH copy 2. So those are kind of primitive tools that are also available if you're interested. So the next type of migration that we're going to talk about is DynamoDB. So ScyllaDB has a DynamoDB client compliant API called Alternator. And so this discussion is going to talk about how you can migrate from DynamoDB to ScyllaDB using ScyllaDB's Alternator API. So again, frequently applications are migrated from DynamoDB to ScyllaDB using Alternator with no application changes required. We'll show an example of an online migration using Scylla Migrator and some alternatives with DynamoDB as well. So similar to the Cassandra migration that we talked about, we're reading and writing now from DynamoDB, and you would create the schema in ScyllaDB Alternator. And then to do an online migration, one of the options is to use streams from DynamoDB. And so you would enable streams. And what this does is it creates a stream of mutations, the before and after image of every change that's occurring to DynamoDB. And it basically puts that in a queue, right? And so you start to accumulate changes to the DynamoDB database. And then we're going to use ScyllaDB Migrator, the Scylla Migrator, to forklift the existing data from DynamoDB into ScyllaDB using the Alternator API. Now, DynamoDB and Alternator do not have this concept of write timestamp. So if we started applying mutations to the ScyllaDB right now, then the forklift data would overwrite it. And so in this case, we're going to forklift the existing data. And after that completes, then we would apply the updates from the DynamoDB streams to catch up Scylla with DynamoDB. And so there's a sequencing here. And I have a line, you can see that the DBs are in sync about halfway through. We keep applying the mutations, and that becomes, after the databases are in sync, that's dual writing, right? And so from that point forward, it's very similar to the Cassandra migration, that we continue to write to both the DynamoDB source and the ScyllaDB target until you've completely transitioned writes to ScyllaDB and you cut over the applications to using ScyllaDB. And so we're writing to ScyllaDB, and we can also start reading from ScyllaDB as soon as the databases are in sync. Actually, as soon as the existing data is forklifted, you could start validating the forklift data. And after the streams have caught up and ScyllaDB is caught up, you can validate the source and target. You can begin dual reads. And after you cut the writes over to ScyllaDB, you can begin the fade off of DynamoDB. All right. And so again, one of the ScyllaDB migrator actually, through a configuration parameter, gives you the option that we're going to use streams. And so it will recognize when the forklift data phase is over, it will then begin applying the mutations from the stream that was created for DynamoDB. And then you just leave that running until you cut the writes over eventually to ScyllaDB, and then there's no mutations coming in through that stream anymore. They're not occurring because you've cut writes over to ScyllaDB. And so again, the ScyllaDB migrator is highly resistant to failures. It has retry logic. We've recently added recognition for it'll distribute connections across all of the nodes, and it has highly performance parallelized reads and writes. Similar to and exactly the same as the Cassandra migration, if we need to speed the migration itself, then we can scale out Scylla Migrator. We can scale out Scylla, the target database. And because the Scylla Migrator and the Spark is based on Spark, and it's breaking the work into little chunks of copies to be done. And so if we want it to run faster, then it's simply a matter of adding worker nodes to the Spark cluster that is running Scylla Migrator, and it can process more. It'll read faster from DynamoDB and apply writes faster to ScyllaDB. And if you've saturated the target cluster, then it's simply a matter of scaling up the cluster, right? So we can kind of go as fast as we need to. We can, there's some limits, but that's the idea, and they both scale really well. Some of the alternatives for DynamoDB migration. Sometimes instead of using streams, the application will have a Kafka queue. And so instead of having to pick up those mutations, what some of our clients have done is they'll mark the offset in the Kafka queue when the forklift begins. And so after the forklift phase is done, they'll just replay the Kafka queue to the target database until it catches up. So instead of using DynamoDB streams, if your application is using Kafka, that's another option that's available. And Scylla Migrator now supports DynamoDB loading from DynamoDB S3 backup Parquet data type. And so we can also use that as an input source to do the forklift portion of loading into ScyllaDB. using the alternator API. All right. So what are some migration tuning opportunities? What else can you do to make this more efficient and to run faster? As I mentioned before, ScyllaDB and Spark are scalable. If we need to go faster, we can scale them out, scale them up, and allow that process to run much faster. Consider over-provisioning the Spark and Scylla during the migration phase, especially if you have restrictions on the streams. Usually we have to catch up within, the forklift has to complete within 24 hours because the queues, the streams would expire within 24 hours. And sometimes the Kafka queues also will have a limit to how much. 24 hours is a good assumption on how long you can keep data in those queues. And so we would like to try and make sure that the migration completes within 24 hours. And since we don't like to cut things close, I usually target for half that. I don't want to have a migration planned for 22 hours when there's a hard stop at 24 hours before we have problems. So the other side is the over provisioning. You can stop the Spark clusters when you're not using them, so you're not paying a consistent high bill on this cluster. You're only going to over provision Scylla for the duration of the migration. You're not going to necessarily run with the over provisioned cluster, so I think it's definitely worth it to do that. Some things you can do during the migration that will also help things out: disabling TTL during the backfill phase we can disable it in ScyllaDB just on the target side, and that way we won't kick off the daily delete process, which would consume some background resources. We could suspend the backups and repairs on the target database. We would increase the minimum threshold for compactions, which controls how many SS tables before a compaction will kick in. We could set that to 4 or 8 or 16 even. We don't want to disable compactions completely because you might end up with too many small SS tables. By upping the min threshold, we'll wait a little bit longer before doing a compaction, and they'll be more productive. You'll have each compaction that does actually occur as you're getting more value out of putting those SS tables together. And we can also set compaction shares to 100 to reduce the intensity of the compaction and how much resource it takes compared to the backfill process itself. So these are just some things that we can do to make the migration go a little bit faster. All right. The other thing and this is just probably the thing that I do the most that I never regret, is to test the migration throughput. When you're using something like Scylla Migrator to do the backfill, that's usually the part that takes the longest, and we're most concerned about its performance. When you look at the performance graph for Scylla Migrator, it tends to look like a mesa. So it spikes up, and then it's flat, and then it comes down when it's done. And what's beautiful about that is if we just run for a little while on the proposed migration topology, right? Whatever the instance size is and the number of instances for both the Spark Migrator as well as Scylla, we can get a good feel for how many items we're writing per minute, and then we can kind of project out whether we're going to meet our target or not, and see if we have to make any changes to the migration. So definitely practice the migration and get a feel for whether you're going to meet your throughput requirements. And then we could just terminate it, truncate the target, and then schedule the real execution when we know we're going to hit our throughput goals. So other migrations, from an SQL database, MongoDB, we do see migrations from these other databases. They typically do require application changes because we're not API compliant. And so there will be some data modeling and ETL style migration with application consideration required. You can still follow the principles that we talked about in this session about following dual write and backfill principles to make sure that you can have an online migration where you're writing to both the source and the target, and give you the opportunity for dual writes and dual reads, and being able to fall back or proceed when the source database gives you the performance and the data is validated on the target. So we do see these types of migrations, right? And they have also been very successful. So hopefully you learned a lot about ScyllaDB and how to migrate to ScyllaDB, whether you're using CQL or whether you plan to use Alternator. We have the capabilities to help you, migrate over and do it online and as quickly as possible, right? ScyllaDB scales well. We have many migrations successful with no changes, and you can do it. Don't be afraid to reach out and ask us for questions. We do this all the time, and we'd love to talk to you. Thank you so much.